Today I'll be showing how I've created a balancer module for things like LiPo, LiPo4 and lithium ion battery cells. This is my newest version that I've come up with after a little bit of development. This was the first prototype and I had quite a lot of problems with it. First off, the MOSFET was overheating. It was just getting roasting hot and I couldn't understand why. And I had two 3.3 ohm resistors in parallel for discharging, and this one works slightly differently. It's using the internal voltage reference of the Arduino. I won't go too into that just now, and basically allowed me to adjust the voltage of the potentiometer, but the MOSFET overheating was the biggest problem and the whole thing just got really hot. So this is my newer version. And basically it's a lot neater and it seems to work better. I'm just using one resistor and the MOSFET gets barely warm. It gets very slightly warm and it has no heat sink on it. So I'm a little bit puzzled by that one. So this is the basic layout on a strip board. So what we've got here is basically where we put in the headers for the Arduino to sit. I've just carefully cut around them so that each little position is separate, and I've got another one that's just cut out there, and that's for a resistor just to go in between there, and that's all there is really to it. And that'll help me lay it out. So I'm going to assemble a few more of these and then I'll go over the program code and how to set them up and calibrate them. But before I do that, I'll just show you a demonstration of it working. So here I've got it set up. The red light flashing there, that's a feature that I've put in so that when I open the battery box I can inspect them all, and if that red light is flashing, it just basically means that the Arduino is alive and it hasn't crashed. The other red LED, I'll make it apparent what's happening with that just now. So I'm going to turn the voltage up. When it hits 3.5, the balancing should start. And basically what that's trying to do is hold the voltage down at 3.5, but due to the voltage drop of the cables coming from a power supply, it's pretty unstable. When you connect it up to a normal battery, it's just going to have a very short length of cable there, and voltage drop wouldn't be as much of a problem. So it is a bit unstable there, but that's the basic operation. As soon as the voltage gets up to that certain point, it simply drives the MOSFET and discharges into the resistor. I'll put a circuit diagram of it up as well. So this here is the circuit diagram. The LED that flashes to show that the thing is alive, that's actually internally on the Pro Mini itself, connected to pin 13, so it's just not shown here. So you can screenshot this or whatever for the circuit diagram. The code I will link to, I've got that uploaded somewhere. But during the calibration process, the thing that you've got to pay attention to is this line up here. You have to change this value until the voltage that is sent over serial matches what's on your multimeter. You just play about with this value and keep on uploading it until it's correct. And it is meant to use the internal reference, which it is, and it was working before, but for some odd reason all the internal reference things have gone off. I don't know what's happened, so I've had to make the value larger for all my Arduinos because before you would just measure the analog reference pin after running a setup sketch and you get a voltage and you just put it in here, but it's quite complicated and it stopped working for some reason, so this way is better. You just simply play about with this value and you usually only have to change it by about by like this much, putting it up to 1.23 or 1.235. So that's all you really need to pay attention to in here. And if you want to change the voltage that it balances at, it's just this line here. So this is a Pro Mini 3.3 volt 8 megahertz version. So this USB to serial converter actually has a switch in it where I can set the voltage down to 3.3 volts, and it's actually 3.19, but if you don't have that feature where you can turn the voltage down, you would have to remove the Arduino from the module. So, and that's why I've put these headers in, so you can just unplug it if your converter is only 5 volts. Supplying 5 volts to a Pro Mini 3.3 volt will not damage it, and that's provided your project is also, that's provided it's not connected to a project which expects 3.3 volts across all its systems, but it won't harm the device itself. So on the screen it is reading 3.19 volts from the serial output. So simply just to make sure that's correct, all you're going to do is simply just measure the supply voltage. So you just put one probe to ground or one to VCC, as simple as that. And on the multimeter, switch it to volts. It's shown 3.2 on the multimeter, but 3.19 on the screen. So simply all you can do is, this is obviously after you've uploaded the sketch and everything, I just changed that value I showed. So it's reading too low on the screen, so I could simply change it by 0.005, so I could put 1.125 like that, and then upload it, and then see if that changes the value on screen. So we'll click upload. It's just uploading to the device just now, and we'll just wait till that's done. We'll look at the serial monitor again. That's saying 3.21 on screen, and we'll just verify that's correct. Still 3.2 on the multimeter. So we can maybe take it down by a little bit, but it's just basically playing with that value until what's on the multimeter matches the serial output coming off the Arduino. And once you get that right, once you get all that calibrated, it's basically ready to go. It's ready to be installed on your battery. So I'm going to get the rest of these made up, and then we'll see if it actually does work or not. Okay, so it turns out that the analog reference thing is actually working. It's where you measure the voltage on the analog reference pin. So I'm just going to show you how to do that just now. And this should make calibration quite a bit easier. So what you want to do is, you want to upload the reference setup sketch to the Arduino, the one that I'll provide in the link. And what we're looking for after you've uploaded that is you want to read the voltage on the A ref pin. Now on the Pro Minis you can't get access to that. You have to go directly to the chip, and A ref is the 4th pin up on this side here. So start from the bottom there, it's 1, 2, 3, 4, it's that one there, so you need to read the voltage that comes on that. You'll need a multimeter that could go to at least 3 decimal places, so I'll set mine to the 2 volt range. I can't really hold the camera and do it just now. Well, I could give it a try, but you connect one of the wires to ground, and you would just connect the other one to the A ref pin, and then you get the value of the of your internal reference. It's meant to be 1.1, but in reality between each Arduino it varies. So I don't think I'll be able to do this. Hold on. Okay, so when you touch that to the ARF pin, you get 1.089 volts. 1.09. So what we'll do in that case is just into the actual battery balance module sketch, you'll just put 1.089 in there up the top, and that should result in the serial monitor giving out an accurate voltage. So now when I measure the voltage of the supply, once we've uploaded the new sketch, it says 3.2 on the multimeter is the value of VCC, and it says 3.2 on the screen, so that's it now calibrated. So we can put this one aside and move on to the next one. Okay, so I've moved on to the next one, and I've done exactly the same thing, calibrated it in exactly the same way, but for some odd reason this one's outputting 3.14 when the supply voltage is still 3.2, so there's something quite strange going on. So in that case, when you come across an Arduino like that, you just have to play with that IREF value up at the top until the serial output matches the multimeter. Okay, so that's all installed now. My light's flashing away there. So what I'm going to do is charge the battery and then start observing what happens when all the cells start getting up to 3.5 volts. My cell log 8Ms are horribly off. They're quite inaccurate, so I need to get them calibrated. So I've bought a more expensive multimeter for that, so I'll just be using these, since these are a bit better calibrated than the cell log devices. There we go, and now as you can see the first cells are beginning to balance. So the good thing about this balancing system is it responds very, very fast. Now if you saw my other videos, these would just flash on and then flash off, so it means it's sort of, I'll discharge for a second, go off and check the voltage, but these are like probably checking the voltage maybe 50 times a second. So they seem to be holding it nice and steady. Still pulling 200 watts into the battery. Yeah, but this one here is obviously going a bit high, 3.52, so it can't keep up with the current I'm putting in just now. So I can always just turn down the current. So I can just do that just now. So when I turned it down, pretty much the whole lot of them just went out there. So I'll monitor it for a little while, and then once they're all up at 3.5 we'll see what happens. Okay, so we're a bit further into the balancing process. I've been monitoring the temperatures of the MOSFETs and they've been getting only slightly warm. So what I've done is I've put heat sinks on them, and then what I'm going to do is add an extra power dissipation resistor. So we'll be able to dissipate about 2 amps per cell. I don't know why my first prototype was overheating the MOSFETs. I haven't a clue, but these ones, the MOSFETs just aren't producing any heat at all, hardly. But that cell there has always been quite high from when I got the battery, but it might have been inaccuracies with these that's caused that. So I'm going to leave these to balance for about 2 hours or so, and until they're all flashing, because these two here aren't doing anything, and they've been inactive the whole time. The rest of them are flashing away nicely though. So I turned the charge current up a bit, and now they're just on solid, most of them, and they're still holding the voltage quite well. So they seem to work well. These ones over here are sort of flickering and flashing, but the rest are just solid on, and there's obviously that sort of hot smell coming off it, and that's just the resistors. So I'd say the system is doing really well so far, but I would like extra resistors on there just to balance the batteries quicker. So to give an idea of just how fast these are responding to voltage changes, I'll put a speaker on one of them here. And that shows sort of how quickly they're measuring the voltage and responding, and it seems to be, it sounds roughly like 50 Hertz. The older prototype was running at 16 megahertz instead of 8, and that was quite a bit faster. And running at 60 megahertz, it probably would have worked, but Atmel do not recommend it. Atmel make the chip that's on these Arduinos, so for greater stability and reliability, that's why I chose the 8 megahertz version. Okay, so I think I've determined what was causing the MOSFET to overheat on this in the past. So the MOSFET was right here at the end, and I've just felt one of the legs coming off these resistors, and the resistors I've deliberately placed them further off the board like this, and the wire legs coming off them are absolutely roasting. Now on this there was two of them, two very short wire legs there for two resistors, and the MOSFET was right there, so it was conductivity, thermal conductivity through those wires there and then into the MOSFET, which was causing it to overheat. Not so much because it was being driven incorrectly. And I felt underneath the boards as well, and there's still a bit of heat conducting over, so maybe it's best that I don't add another resistor. I'm not that sure what to do. Probably an amp of balancing current is fine for this small battery bank, but eventually when a seller that I bought these from gets the Nissan Leaf cells in stock, I'll be buying a huge amount of them, so I'll need more balancing current.